All right, and welcome to the bedroom. And you might wonder why there's a red light in here. And you better stay tuned to the Light Guru course, which is coming up next, because there's a very important reason why you want candlelight or red light only in your bedroom, and we do not compromise on that. Okay, now this is what I want you to do: is if you get these meters yourself or you borrow some meters from somebody, sit down in your bed and lay down in your bed. So this is how the building biologists actually check this: is they have you lay in your bed as you would normally be laying, so not quite like this. And then you're going to check your body voltage, which we're not going through in this episode. You can look that up next if you want to find body voltage and how to test it. You're going to take your meters, and this is the only wall that our bed touches right here. So we want to check if there's electric fields and magnetic fields coming out of this wall and anywhere around where we're laying in bed. This is your area of sleep and recovery. And so you want to be very low EMF where you're recovering. This is your most primal environment here. Now, we also have a very high magnetic mattress on this bed. So a Magnetico mattress that has a 10 Gauss, not milligauss, 10 Gauss field, static magnetic mattress underneath the mattress of this bed. It's at the very bottom. It's very heavy. It weighs about 200 to 300 pounds. And that helps set the environment here. So we're not going to measure the magnet under the bed, but we're going to measure what's coming from the wall. So I take your meter and just use it kind of where you're laying. So I'm going to look at the meter here. And remember, we were like 100 with the appliance turned off and about 600 with it turned on. Now I'm at 14 volts per meter. 14, that's almost the lowest I've seen just about anywhere. Now I'm going to put it up to the wall because I know kind of where our heads are seems pretty safe. Let's put it by the wall. And you can turn it to different angles. And I'm getting 48, 47. So again, it was 19 about where my body is, but right against the wall, we're at about 48 to 50. I'm going to turn it this way and I get 35. I'm going to back it off a little bit. 29, change the direction. 23, 21, 15, 14, 14, 11, 10, 9, 8, 7, 6. So right about where my feet are here, we get about 6 volts per meter. Right against the wall, we're getting about 50. So if you were setting up your bedroom here and you're not going to turn the power off to this wall, you'd probably want to be about a foot away from that wall, ideally, to get the lowest electric field possible based on these readings. So right now I'm looking at 7 volts per meter. That's about as low as you're going to get, and that's about a foot away from the wall. So that would be ideal. That kind of tells you how you can set up your ideal bedroom environment. That's the electric field. We can test the magnetic field. So let's test it out here. I'm going to turn it on and let it sit steady for a little bit. So we're at 1.1 milligauss. So a little higher than I would like. I would like it to be a half, 0.5 or less. Right at the wall, it's the same. It's 1.04. And I'm just going to go to the center of the bed and set it down. 0.64 at the level of the bed. If I go a little higher off the bed, so this is what I want you to do: is check different levels to see where the magnetic field is. So a little higher off the bed, I'm at about 0.9 to 1 milligauss. And then what you're going to do is, we checked this side, you would then check the other side as well. You can see there's different switches and different appliances plugged in. We're at 5 milligauss over on this side of the bed. So when we move back to this side, we're at 1 milligauss. So this is why it's important. I didn't actually know this. This is why it's important to check both sides. So let's do it a little bit lower here. 1.4 milligauss. Actually, the closer to this switch you get, the higher the magnetic field. I'm just going to do another test here. 1.2 milligauss. Level of the bed, 1.5 milligauss, and then center of the bed, 0.8 milligauss. So this kind of just tells you, like, even within this bed, there's different areas that have higher and lower magnetic fields, and that will change as current flows through the circuits here. The magnetic field becomes higher. When the current is sitting doing nothing and it's static, there's almost no magnetic field. Its magnetic field is created with moving electrons, moving charge. So when you've got electricity running through the wire because something is turned on, that's when the magnetic field gets bigger. So if we have an electric heater up here, every time that electric heater clicks on, the magnetic field is going to get really big. And when it turns itself off, because it reaches the right temperature, the magnetic field will go away just about. So those are things to keep in mind and to test in your bedroom. If you have an electric blanket, we don't even have one of those to test. Very dangerous to have the magnetic and electric field on your body all night in those electric blankets. Be very, very, very careful with those. So come to your bedroom, come to your kids' bedrooms, your guest bedrooms, all the places you spend time in your home, and check the walls, and then check where you actually physically spend the most time, your space, and how does your space look versus the walls and some of the outlets and some of the appliances that are around you. Again, we found in our kitchen that the Cuisinart toaster oven emitted a huge, huge magnetic field, bigger than we would have imagined possible. And so we actually keep that turned off on a power strip unless we're using it, and we try to keep our distance from it when we use it. Our refrigerator, surprisingly, was very low. Other people's refrigerators are the highest magnetic field in their house. So check all your rooms with your meters, and we'll link you to where those meters can be found in the email that you got. And until next time, this is Thaddeus, and Heidi's behind the camera. We'll see you next time.